at the night sky, you find the faint red dot low on the horizon. You've seen it 100 times. You've probably never thought twice about it. But the real answer to what it would take to live there is far stranger than you imagine. Mars is not a red planet you visit. It's a red planet that tries to kill you every second you're on it. And yet humans are already planning to go. So what would actually happen if you stepped off that ship and onto the dust? Start with the journey itself. It takes about 7 months to get there, drifting through a vacuum with nothing but thin metal between you and instant death. Your body doesn't know the difference between floating in a spacecraft and floating in a swimming pool, so it starts shedding what it doesn't think it needs. Bone density drops. Muscle wastes away. Your heart, no longer fighting gravity, begins to change shape. NASA learned just how much the human body changes in space through an unusual natural experiment. Astronaut Scott Kelly spent nearly a year on the International Space Station, while his identical twin brother, Mark, stayed on Earth. Researcher Susan Bailey studied their telomeres, the protective caps on the ends of chromosomes, and found that Scott's actually lengthened in space, then snapped back rapidly once he returned to Earth's gravity. His body was reacting to stress at the cellular level. And that was in orbit, still shielded by Earth's magnetic field. Now imagine 7 months with no shield at all. Which brings you to the first real threat. Radiation. Earth has a magnetic field wrapped around it like an invisible coat. It deflects the worst of the sun's radiation and cosmic rays from deep space. Mars lost its magnetic field billions of years ago. Nobody knows exactly why. Some scientists think its core cooled too fast. Others think it was stripped away by a violent solar event. Either way, the result is the same. Mars has almost no protection. Without that shield, radiation hits the surface constantly. It's not the kind of exposure you get from an X-ray. It's a slow, cumulative bombardment that raises your risk of cancer, damages your central nervous system, and can even affect your cognition over time. So how would you survive that? You wouldn't live on the surface, exposed. You'd build down, not up. Early Mars habitats are being designed to sit beneath the soil itself, or inside natural structures, like lava tubes, tunnels left behind by ancient volcanic flows. The Martian dirt above you becomes your radiation shield. Thick walls of soil, sometimes several meters deep, block most of what would otherwise tear through your cells. This isn't science fiction anymore. It's the working model for almost every serious Mars mission concept today. Aerospace engineer Robert Zubrin, who has spent decades designing feasible Mars mission architectures, has argued that survival there depends on using what's already available on the planet instead of hauling everything from Earth. His plan calls for manufacturing fuel, water, and building materials directly from Martian resources, because every extra pound launched from Earth costs a fortune. That idea, using the planet against itself to survive it, shows up everywhere in Mars planning, and nowhere more than in food, because you can't ship a colony's worth of groceries across space forever. So how would you actually eat on Mars? The soil itself is toxic to plants. It's full of chemical compounds called perchlorates, which are harmful to humans and disruptive to most crops. Before anything grows, that soil has to be treated, washed, or bypassed altogether using sealed hydroponic systems, growing plants in nutrient-rich water instead of dirt. Light is another obstacle. Mars gets less than half the sunlight Earth does. Greenhouses would likely need supplemental LED lighting tuned to the exact wavelengths plants use for photosynthesis, running around the clock in some modules to make up for the difference. Researchers have already tested versions of this life. In Hawaii, on the slopes of a volcano that mimics the isolation and terrain of Mars, scientist Kim Binstead led a series of habitat simulations called HICs, where small crews lived for months inside a dome, growing food, rationing water, and communicating with the outside world on a 20-minute delay. the same delay you'd experience actually messaging Earth from Mars. What her research found wasn't just about crops or oxygen levels. It was about people. Isolation wears on the mind in ways that are just as dangerous as any radiation dose. Small conflicts grow large in a sealed space. Boredom becomes its own kind of hazard. So surviving Mars was never only a technical problem. It's a psychological one too. Now picture a single day inside that life. Once the systems are running and the crew is settled in. You wake up in a room lit by simulated dawn because there's no window worth opening. The air recyclers hum. Somewhere behind the wall, pulling carbon dioxide out and pushing oxygen back in. You check the readings on your suit before doing anything else, because stepping outside without it means death within minutes. The atmosphere on Mars is less than 1% as thick as Earth's, and it's almost entirely carbon dioxide. Without a pressurized suit, the moisture in your eyes and on your tongue would begin to boil away almost instantly, even in freezing temperatures. You eat a breakfast grown 2 rooms over, harvested the day before. You run diagnostics on the water reclamation system because every drop, even the moisture from your own breath, gets captured and reused. Nothing is wasted here. Nothing can be. Outside the viewport, the sky isn't blue. It's a dusty butterscotch color during the day, and at sunset, oddly, it turns blue, the exact reverse of what you'd expect on Earth. That's because Martian dust scatters light differently than Earth's atmosphere does. You suit up to go check the solar panels, half buried in orange dust from the last storm. These storms can grow large enough to wrap around the entire planet, lasting weeks and blocking out enough sunlight to threaten your power supply. You brush the panels clean because you have to. There's no repair crew coming. That's the version of Mars survival that already seems achievable within a few decades. But there's a bigger question hiding behind all of it. What if you didn't just survive on Mars? What if you tried to make Mars survivable on its own terms? That idea is called terraforming, reshaping an entire planet's atmosphere and climate to make it more like Earth. NASA scientist Chris McKay has studied this question seriously for years, exploring whether Mars could be warmed enough to release the frozen carbon dioxide and water locked in its polar caps and soil, thickening the atmosphere and eventually allowing liquid water to exist on the surface again. In theory, releasing enough greenhouse gases could raise the temperature and pressure over time. In practice, his own research suggests the numbers likely don't add up. There may not be enough frozen carbon dioxide on Mars to thicken the atmosphere as much as once hoped. Even in the most optimistic models, the process would take centuries, possibly longer, and would still leave you needing breathing support, since more carbon dioxide doesn't mean more oxygen. So terraforming isn't a quick fix. It's a multi-generational gamble, one where the people who begin the project would never live to see it finished. Which leaves you back at the smaller scale. The dome, the dust, the daily discipline of keeping every system running. Because on Mars, there is no atmosphere to forgive a mistake. Could humans survive there? Yes, almost certainly, in bunkers beneath the soil, breathing recycled air, eating food grown under electric light, watching a red horizon that never quite looks like home. But survival was never really the hard part. The hard part is what happens in your mind, staring at the same domed ceiling every day, hearing the same recyclers hum, waiting 20 minutes just to hear a voice reply from a planet you can still see, faint and red, low on your own horizon back home, which means the next time you look up at that dot in the sky, you're not just looking at a planet. You're looking at the hardest home humanity has ever tried to build. Thank you all so much for watching. This means a lot to me, so if you enjoyed, make sure to like and subscribe and tune in to the next one.